Hello friends, welcome to our online channel. Myself CCJadhav. In previous lecture we have seen that the functions of the graphics software, there are 5 functions. The first, generation, transformation, display control, windowing function, segmenting, editing and user input. But for that functions some requirement from the CAD software is there. So we will see one by one what are the requirements for the CAD software for this graphics of the graphics software. So first, that is a simplicity. The software should be user friendly and easy to handle. Consistency next, it should be operate in a consistent and predictable manner. Next, robustness, graphics software should have robustness. Next, performance, the software should be efficient and must have high speed of response. And last, that is economic, that cost must be optimum for that software. So these are the some requirement of the CAD software for the graphics software. So our software should be user friendly and easy to handle. It should be operated in consistent and predictable manner. It should be robustness in nature. It should be efficient and must high speed of the response in terms of the performance. And last, the cost must be optimum. So this is the some requirements of the CAD software for the graphics software. So next part, that is a hardware in the CAD CAM CE system. Now you can see the image of this CAD CAM hardware in CAD CAM CE. One design workstation system is there. In that, graphics terminal and input device is there. Then secondary storage, CPU and output devices. So this is the typical configuration of the hardware components in CAD CAM CE system. So hardware used in CAD system includes design workstation, digital computers, that is the central processing unit, output devices such as plotters, printers and various secondary storage devices. So in that, first we will see that is a design workstation. In that, the design workstation consists of the display terminal, that is our graphics terminal, and a set of the user input devices with which the user interact with geometric model by entering and numeric data, entering system command to perform various graphics operation, and by controlling cursor position on the display screen. So in that design workstation, in that graphics terminal or display terminal, we are using various input devices for the giving, inputting the various information related to that part, that is numerical data. In that, we are going to give input for the various graphics operation for controlling cursor purpose. This is the use of the first terminal. So next, digital computers. This uses of high speed data center processing unit to process a CAD operation. Okay, in this digital computers, that is a CPU. In that, we are going to use this high speed computer for the giving or doing the CAD operations. So next, that is output devices. In this includes plotters and printers which generate the output from the CAD system. Whatever we are providing in the design workstation as input, our graphics terminal, that input we are going to convert into output with the help of these plotters, printers. We are generating the output from the CAD system. Next, that is the secondary storage, and this system includes various storage devices attached to the CAD system to store the programs and data files. Store the programs and data files. The storage medium is used can be DVD, CD, external hard devices, magnetic storage system and server center point. So there are different system devices is there to store the data programs in the terms of the CD, DVD hard disk, pen drive. Okay, so this is the secondary device. So this is the overview about the hardware used in CAD CAM CAE system for input purposes, generating output, storing all the data related to that part, and doing the CAD operation. For that we are going to using the high-speed computer, that is a CPU unit. So this is the hardware in CAD CAM CAE system. Next, functions of the graphics workstation. So what are the functions? We will see one by one. It must interface with the central processing unit. It must generate a steady graphic image for the user. It must provide digital description of the graphic image. It must translate computer commands into operating functions. It must facilitate communication between the user and the system. So there are some important functions of the graphics workstation. It must interface with central processing machines. Whatever we have given input, that input file system must interface between the CPU, and it must be generate a steady state image for the user. Whatever given input data for that machine, from the data, that machine or that graphics workstation must generate some steady graphic image for the reading purpose of the user. It must provide some digital description, whatever information related to that part, that system must provide some digital description for that image, and it must be translate that command, computer commands, into operation functions to the machines, and some communication must be there in between users and that system. So these are some functions related to the graphics workstation. Next, components of the graphics workstation. So there are two components in that. First, graphics terminal, which is the display terminal, and operator input devices. This is the major components of the graphics workstation. In that first, graphics terminal, which is going to provide some display, or which is going to some display the whatever we have given the input devices, input program to that system. That system we are going to display that files, and we are going to create some 3D model by using the CAD system. That system we are going to display on this terminal. And operator input devices, that means we are going to giving some program files in the terms of the input. Okay, so that time we are going to do some input devices like keyboard, digitizer. Okay, like this there are many input devices for inputting our program that we are going to display on our graphics terminal. So these are the components. So now you can see this is the image generation process in the computer graphics by using the cathode ray tube. So by using this cathode ray tube, we are going to create the image in computer graphics. So these are the one of the method to create the image, generate the image from the given input file. So in that CRT we are using the phosphorus coating for displaying that image on the screen. Electronic beam is there, CRT screen is there, focusing system, control grid, and cathode. So by using this cathode ray tube, we can generate the image in computer graphics system. This is one of the example of the image generation in computer graphics. There are some approaches or techniques to generate image on cathode ray tube screen. So first, there is a stroke writing, and second is a raster scan. So there are two methods to generate image on the CRT. We have seen the previous working of this CRT. So by using this CRT, we can generate the image by two approaches. That is the first, stroke writing, and second is a raster scan. So this is simply two approaches for the generating the image on the graphics terminal. Next, types of the graphics terminal according to this system. The first, direct beam refresh. Second, direct view storage tube. Raster scan, that is a digital TV. So in that we'll see one by one the difference between these three types of the graphics terminal. One by one we will see it at the parameters. There is the image generation. So in that direct beam refresh, they are using stroke writing. In DVST, second type of the graphics terminal, they also writing with helping the stroke. And last one, raster scan, they are using raster scan. Picture quality, in that excellent we will get in direct beam as well as DVST, and moderate in raster scan. Data content limited in data direct beam, high data content will get DVST, and high also raster scan. So selective erase process is able to in only direct beam and raster scan. There is no in DVST. Gray color occur in direct ST and raster scan. Color capability moderate in direct beam refresh, no in DVST. Raster scan yes. Animation capability yes in direct beam refresh, no in DVST, and moderate in raster scan. So this is the difference between these types of the graphics terminal. Next point, that is the types of input devices. So as per according to text input, graphics input, and direct input devices. So there are some types of input devices, that is we are just regularly using these input devices like mouse, trackball, joystick, light pen, digitizer, scanner, barcode reader, biometrics. These are the example of the input devices. So we'll see one by one. We can see this is the images of the input devices. In that first input devices, that is a keyboard. In the keyboard is a primary inputting text by pressing a set of the keys. In general, computer keyboard has following keys. That is first alphanumeric key. It includes letters and numbers. Punctuation key, it includes commas and semicolons, etc. And next, that is the special keys. This can be a function key, control key, cap lock key, and allows key. So like this, we are going to using this keyboard. In this there are some type is there. So keyboard type, that is original PC keyboard, which is having 84 keys. Advanced technology keyboard, which is having 101 to 104 keys, and multimedia keyboard, which is having 120 to 140 keys. So this is the in device keyboard. Light pen, we are using this inputting data as a graphical format on the screen with the help of this light pen. Next, scanner. Scanner, basically we are using the scanning purpose, the documents. We are storing that data in the form of the soft copy. Next, that is a output devices. Before that, going to output devices, we will see some input devices. That is a joystick. Joystick is a device used for the playing video games as well as the user for the controlling machines such as the cranes, trucks, industrial robots. The user moves a spherical ball with the help of the stick in the joystick. So this input we can use in games also and in industrial purpose also. Next, trackball. Trackball is a movable ball mounted on the stationary device which can be rotated manually by using the fingers. There are used in playing video games. So for video games we are using this input as a trackball. So next is a digitizer. So these are used by architects, engineers and designers in CAD for designing a purpose such as building cars, mechanical components, robots. For making some part design, for building design, that purpose designers and engineers, architects, they are using this type of the input devices. So these are the input devices. We will see next point, that is a output devices. So in that output devices, you can see there are some type of the output devices. In that, first the printer, so printers, plotters and monitors. So these are the output devices. So from these output devices, the hardware which a computer uses to present data to user in output devices require the information from the computer and translate it from machine language to method that human can understand it. Again, it is classified into the subtype, that is a soft copy output devices and hard copy output devices. So in that, first we will see the soft copy output devices. The soft copy output devices includes all types of the display devices. Display devices are the visual output devices of the computer. The most common types is a monitor. The monitor will display the images or data from the user to observe it before proceeding to hard copy. The different type of the display include CRT, LCD, LED and projectors. So in that, first soft copy output devices, before being a hard copy of that output, we are going to using in a soft copy by using different techniques, CRT, LCD, LED, projectors. So these are the soft copy output devices. And in hard copy devices, these devices will give to user a hard copy of what is displayed on the screen. The hard copy can be obtained by using printers and plotters. So this is the output devices in CAD CAM CAE system. So next point, that is a software configuration. So in that software, that is a graphics terminal, how they are configuration. So you will see first, that is application database, then application program, graphics packages, and last one is the design workstation. In that, input and graphical terms. So we are going to give some input here in the design workstation of that part. From that, we are going to create program, and that graphics packages means we are using various CAD CAM CAE software. We are making the program for that application. We are going to give the database, create the database in our computer system. Like this, we are going to continue these cycles for different part configuration. So this is the configuration of the software. Here we are going to create the model of the graphics software. So next, the history of the CAD CAM CAE. So in the phases of the 1950 to 1960, MIT, that is the university, that is Massachusetts Institute of the Technology, produced simple picture by interfacing CRT and wheelward computer. First invention in the 50-60. Then MIT Servo Mechanism Lab developed on concept of the NC on 3-axis milling machine. Afterwards, they are inventing the light pen was by SAG, semi-automatic ground environment. Then automation programming tool developed. In 60 to 70, computers started to come in research laboratories. In mid of the 60, CAD started coming up. Direct view storage tubes are available. The world design was extended beyond drafting. Afterwards, in 1780, the term is golden era in computer drafting. In 1719, IGS is developed. Then National Computer Graphics Association started. In 1819, the major research in CAD CAM. Then integration of the CAD CAM started. In synthetic curves and surface was developed. Then application of the regarding analysis started. Hardware software which improved features started. In 2000, reverse engineering started. Cost of hardware and software is slowing down. Communication medium is started. Concept of the virtual factory started. Then 2000 onwards, rapid prototyping and 3D printing started. Cost of high performance computer is reduced. Wireless transmission is developed. In this CAD CAM growth, so later words in coming era, we have seen that very automated computers or smart computers coming. So these are the some uh, views or phases of the how CAD CAM CE software is growth. So next point, that is the selection of the CAD CAM CE software. How we are going to select the CAD CAM CE software? So there are some committees there. So selection of the right CAD CAM CE system a critical process. So a careful study and evaluation should be done before finalize the correct software. So in that some major steps and procedure is there. So we'll see one by one. That is the first, evaluation committee. In evaluation committee, comparison of different software with consideration occur and company product take place. Typically the committee could be includes the design, production, industrial engineering and purchase department. So this is the first evaluation committee. Second, what do we need? What is the need of the basic this selection for that software for that particular work? So this committee should set up guidelines to the selection criteria and evaluate the alternative systems. The committee should consider the present and further needs of their requirements while designing the software. This is the second point for the selection. Third, technical evaluation and expert opinion. The committee should correspond technical classification and discussion with the expert and representative of the vendors. So before creating our any software, so some the technical evaluation and expert opinions there according to that software. Next, who is using it and what to do they say? After creation, who are using this? Who will use this? So the technical committee should make the visit and receive feedback from other users of the same software. This hands-on report about the software performs from other user may highlights whole area and problems which are experienced only in day-by-day use. So they are going to testing users from feedback and they are going to see the whole area and problems which are experienced in day-by-day use. And last, there's a creation of the checklist. So from these various sources, a checklist should be developed and based on the list, suitable software should be eliminated and find the alternative, their consideration for the further evaluation. And last point, that is a cost benefit analysis. Finally, a cost benefits ratio can be done to the finalize the CAD CAM CE software. That is the most important part related to the finance. So finally, cost to benefit ratio with that software that will be decided to finalize the CAD CAM CE software. So this is the selection procedure for any CAD CAM CE software. So this is the last point of this chapter, first chapter. So our first chapter will be is over. So thank you so much.
Hopefully you might have enjoyed the lecture. Then please do like the video and know your thoughts in comments. Please do share this video among your friends and don't forget to subscribe to our channel. After subscription, you can press the bell icon to never miss the notification regarding our new videos. Thank you so much.